Hi, today I will be representing a short demo project in Java with Spring Boot. Now, instead of jumping directly into the coding, let me first discuss some of the sites that will be useful as a backend developer. First of all, I must go for this site, which is roadmap.sh. It will, as we are working as a backend developer, and we will be working on Java specifically. So it will tell me all of the skills that will be required to work as a backend developer. As here is diagram in the roadmap.sh, and we can here clearly see it will give us the knowledge about the internet that needs to be as a backend developer. Then we have some version control system, GitHub, Bitbucket, and we have some relational databases, MySQL based on SQL. There are some NoSQL databases as well. Let me see here, like here MongoDB. And apart from this, we must have the knowledge of testing, integration testing, unit testing, functional testing. It is all working with CI/CD, that is continuous integration and continuous development, and they are working on HTTPS API security best practices, and also there are authentication services as JWT, OAuth, basic authentication. And apart from this, we need to know about what the HTTP is, how internet work, what is domain name, what is hosting. Like all these parameters must be known to be a backend developer. So it just gives us a roadmap what we should know to be a backend developer. And apart from this, we will be working on one of the tool as well, which is Eclipse, and here it will give us the visual representation of all the data that we will be using here. So this tool will be used to show the databases, to show the connection or the APIs or the internet services, how they will be working. So we will use these sites. Now, apart from this, let me start with the Stripe payment integration overview. Let me delete this first. Now let's start with this. Here we have a client. Let it be, you can see it as Amazon, we can see. Just an example. And apart from this, we have this payment integration system. And apart from this, we have PSP here. Here we will be using Stripe PSP. As PSP is nothing but the payment service provider. It is payment service provider. Let me show you how will it work. Let me have a customer over here. Now for making a payment, like there is a customer who purchased something from Amazon. So this customer, after a purchase, it will create a REST API here, and to make the payment basically. And then this REST API will create a create session to this PSP. Like in this, we have the call that is made by a customer to pay for a product that has been bought from Amazon or any one of the client. Then a REST API will be called, and then using this payment integration system, this call will be gone to the PSP, the payment service provider. Then in return, this PSP will give us a URL here, and this URL will then be transmitted through the payment integration system to the client page. And using this URL, the customer will go to another page. Like here is a Stripe hosting payment page. Like once a URL will be received by the customer, then the customer will be redirected to payment hosting, Stripe hosting payment page. Once here, the student will submit, the customer will submit all the details and make a payment. Then it will return back to the client page. And once it will be back, there will be another API, like the success or payment failure is still pending with the Stripe PSP. So it will create another REST API here. There is another REST API, and it will give the status for success or failure. Like it is not confirmed yet, but it will be informed here using this API, and this information then be transmitted to the client, and hence the user will be able to get the information about whether the payment is successful or not. Here, this success or failure, we have 5 type of status. As here, we can say success and failure, and apart from this, we have 5 status. One is created, second is initiated, third is pending, fourth is success, and the fifth is failure. So in this way, we have 5 different status. Here the creation is when end customer payment request is valid and it is saved in a database over here. And initiated is just before we call the Stripe PSP. And pending is when we get success response from PSP with valid URL here. And customer is waiting on Stripe hosted page, the payment is pending at customer side in this case. And success is when the payment is successful, and failure is when the payment is failed. In case of failure, there is other options as well. Like there is a possibility that customer is not able to complete its payment. Like it may be possible that customer just leave the page before done the payment, and it's not confirmed a failure in this case. Like it might be possible that customer will be back in 1 hour, 2 hour, 3 hour. Like it might be possible, so we need some expire or checkout section in this case. expire a checkout session. And as we know, for this, like we can also have like we if we have suppose 100 APIs such payments, and we need to call 100 such API calls, and we need to update this data in the DB. So for this purpose we need reconciliation system, where reconciliation system, so what it do, it is basically run every 1 hour or go to DB or pick up all the pending, then check with the Stripe for status. So it can be done using retrieve API integration. For that we use retrieve API integration. So this is how we will be working with the payment integration system of Stripe. So apart from this, let me discuss some of the different architectural styles for building software applications. Different architectural styles for building software applications. One is monolith. Monolith is just built as a single individual unit. So simple, and it is for smaller applications basically. Because in this we have one deployment, and it is very simple and all in one. It is built as a single unit. And then we have SOA, which is service oriented architecture. And in this case, we will loosely couple independent services that communicate with each other over a network. Different services and communicate with each other as a over a network. And the third one is modular monolith. It is nothing but in this, it is just like Spring and Spring Boot. We'll discuss later. And in this we have single deployment unit, where which is just like as a monolith, but internal modulates. Like in this case, we have one main project, and under this there are multiple modules. As I can see here, we have a single main project, but for the different modules we have different jar files. And all these jar files, let me say jar1 1.jar, and for this second jar file, and for this is third jar file. And all these jar files, they are connected with this main project. So this is the case with modular monolith, and this is what we are using currently in the Spring Boot applications. And apart from this, we have the fourth architecture, which is microservices. It is nothing, it is basically a evolution of SOA, service oriented architecture. Here we have multiple services and all running independently. Every service have its own process with own process ID, and they have their own port and own memory separately. Like everything is separate. All of the services, like here nothing but we are working on, like there is one project. As in our case, we can say we will be working on three different microservices. So this is our main payment integration system, and in this system we will be working on three different microservices: 1, 2 and 3. Here microservice 1 is about the payment validation service. The second one is payment processing service, and the third one is Stripe provider service. So we will be working on these three microservices in our project. So in this, like whole project is being divided into its components. Here in our project we will be dividing it in three components: payment validation service, payment processing service, and Stripe provider service. And microservices are working on 9 principles. The first one is componentization via services. As we have discussed, we have three components in our payment integration system. Payment validation service, there are three components. So breaking the project into components is componentization, and the second one is organized around business capabilities. What does it mean is, like we have the size and the function of the components that is manageable, and the team should be capable. In this case, we must have a capable team to do this. The third one is smart endpoints and dump pipes. What does it mean is, like, when we are delivering any data from one endpoint to another, like as we know, in APIs the data is transferred or through the endpoints. So we must have, like here if we can see, we must have these pipes must be dumb, but their endpoints, it must have all the data. And apart from this, we have the fourth principle, which is design for failure. That means we must know the pros and cons of our project. As in our project of this, we have already discussed these status for the failure. Like failure could be any reason, that the customer has not completed its payment because of internet connection, because the customer changed its mind. Like not every action results in the failure. It may be in the pending state, like the customer may later on do the payment. So these may be the failure cases that must be discussed before implementing. And apart from this, we have the fifth principle, which is decentralized data management. Like in this case, as we can see, we have AWS, which is, as we know, it is protected using WAF, which is web application firewall, for the security purpose. As we know, whenever we call API, that is open for everyone. Like even the hackers can work on those APIs. So to prevent that, we will be having this web application firewall along with AWS. AWS can have multiple locations. So if one is, like, we must consider the situation when some disaster may happen. So in that case, we must be have data centralized to AWS kind of thing, so that it can be, if there is some disaster or earthquake like at one place, we can get the data from the second place. So in this way, we must have decentralized our data. And the sixth point, we have infrastructure automation. What does it mean is basically the scaling. Scaling is, we can have scale up, scale down, scale vertical, or scale horizontal. What does it mean? Like we have a service here, let me explain. Here we have a service, and suppose there is, like, the users are increasing, or we can say the load is increasing. In this case, load is increasing. So what we can do, we can create more such services in the same way, more such services. So this is scaling up, scaling up. In the same way, if the load decreases, then we do scaling down. Load decreases, we do scaling down. And also we can have the scaling in the way, if we have the service of this size, we can increase it to this size. So this is a kind of vertical scaling. Like if we can say we have the data for 2 core, we can increase it to 4. In this way, we call it as vertical scaling. Or we can have multiple services. We can, like in this case, although we can extend it multiple times, but there will be a limit that it could not be extended further. So in that case, we will use that final limit and create the services of that. Like if I say This 4 is fixed. So I will create multiple services of 4, and this is a nothing but horizontal scaling. So in this case, we have the infrastructural automation, and apart from this, we have decentralized governance and products, not projects. We will discuss them all later in detail. And the last one is evolutionary design. So these are the 9 principles of microservices that must be done before working on this. Now, as we know about the microservices, let's we continue our discussion for the web framework. Here we have 4 different types of framework. The first one is MVC framework. MVC is nothing but it is model, view, controller framework. And here the view will return back. Like view is nothing but the front end that will be visible to the user, and model plus controller is serving for backend, where it follows 4-layered architecture that includes presentational layer, which is basically control plus view, and we have service layer, which contain the business logic, and we have the DAO, or we can say repository, that have database related logic, and last we have integration layer, which is nothing but external calls, as we know. So in this way we have 4 type of framework, as one is MVC, the second one is web service framework, the third one is data access framework, the fourth one is enterprise or application framework. Next, now moving further, let me explain about the REST API word that we have used earlier over here. REST API is nothing but it is representational state transfer application programming interface, and it is nothing but it's a way for two software system to communicate over the web using principles of REST architecture. Let me write is a way for two software systems to communicate over the using principles of REST architecture. Now let's learn how to set up a Spring project using framework. So we will do it. First, we need Spring Initializr, and in this we will fix some of the data. As here the project we have Maven, language is Java, and for this we will use the latest stable Spring Boot. As these are not stable, so we'll use 3.4.8. And then for the project metadata, let's the group name is com.demo, and artifact, let it be Spring demo, and the name will be same as of the artifact. Group is nothing but just like a company name, and description is demo project for the Spring Boot, and the package name will be this, or we can name it other as well if want, and the packaging will be jar. The Java will be 17. We will be using 17th version of Java. Then we need to add some dependencies, which is nothing but the libraries that will be used, right? Web over here, so we will be adding Spring Web dependency, and after this let's generate. So a zip file will be generated in our downloads. Let's export or extract it to one of the file I have created in D folder, ctws. In the explore I have demo1, so let me save it over here and extract all data. Now I will open my Eclipse, my IDE, and I will launch this. So here is my IDE. So first I will import my project as, then I will look general, existing project. I will browse in my D, ctws, explore demo1, and here is my complete project. So I will add this path over here. I think I did something wrong. Let me redo. I can import project from here as well. Go to Maven, existing Maven project, browse it in my D drive, ctws, explore. This is my folder. So I get the file and let me finish. And hence here I'm able to see my project. Here as I can see I have already GitHub, but for the reference or for the help I can add from the help center. We have Eclipse Market, so from here we can add other data, like I have already added GitHub Copilot. So once we can search from here, for GitHub Copilot. As we can see here, there is no install option as I have already installed it. And then I can also add Sonar Cube as they will help me in my projects, like for the testing purpose, for anything I have error, like it will help me to find it in the starting rather than later on finding something wrong. So I'm not able to get it. Let me check the installed ones. No, Sonar Cube. I don't know why I'm not getting it, but I have already installed it, so you can also uh, install it from here. Now, apart from this, let us check for the version of Java. For that, we will go Window, Preferences. Here we have Java, install JRE. Here we can see we have Java 21. So we need, as we have installed Java 17, we worked on project in our Spring with Java 17. So we must have Java 17. So what I do is I will add, as I can see, I can add it from here in standard VM. Let me show the directory I have already installed in my sorry, not here, but in my C, in my program files in Java. Here we have the Java JDK 17. So I will select this and since I have already used this name, so I can, let me close it, select from here and apply, or we can say apply and close. So now let me check again, Window, Preferences. Now I'm using Java 17. Now click Compiler and here we need to use 17 and apply. Say yes and apply and close. Now if we check for the preferences and install JRE, so we are using 17, Java 17 here. So we have updated the version of Java as well. We have installed GitHub Copilot and we have added Sonar Cube, which will be helpful in editing the code, the checking for the errors and all. Now moving further, let's see our project here. Here we have this POM file which have all the dependencies we have added through this Spring Web, and whatever dependency we want to add manually can be added here itself. Now we have version 17 in every dependencies, and apart from this we have one more dependency, and which is, let me show you, which is DevTool dependency. How it is helpful, like whenever we are editing the Eclipse, if we don't have DevTool dependency, we need to manually build it, and we need to like whenever there is error and whenever we will run, only then we would be able to get that error. But if we have dev-tool dependency, we will get our errors in the early stages. So it will be better if we can add it, and whenever you are adding any dependency, check for the version. If it is there, try to skip that so that it can manually add its version. So we have added the dependency dev tool. Next, what we can do next is right click. One more thing, here we have MJ. M is for Maven, J is for Java based project. So right click over here, run as, then we need to go for Maven build. Then in the goals, we must write clean, as we have commands for Maven clean as it is already Maven. So let it write clean and then apply and then run. So let it save first. Now it is cleaning, it is finished. Next, again right click, run as Maven build, and here we can write package. This is for compiling your Java code, run test cases, and it will build a jar file. Same, it is running. And it is showing some of the errors. Just skip for now. Next, right click, run as Maven build. Here we will Spring Boot colon run. Let me check it at ChatGPT whether I'm using the correct syntax or not. So it is saying yes, it is correct. So let's apply and run. Now it will execute the Spring Boot application. So here we can see on the right side, whenever it is saying Tomcat started 8082, like this is the default port 8082, 8080. And if I want to, let me rerun this again. Run as Maven build, and if I write it again, Spring Boot colon run, apply, run. Yeah, here it is saying web server failed. Port this was already in use. What does it mean is, like, on one port only one service can work upon. Now if we want to run this again for the second time, what we need to do is, in the application properties, here either we need to change the port, as it is not written for now. We have the application properties which is showing default port 8080, and if we want our second service to run, it should be on some other port. Either we have to close the previous run or build application, or we need to change this port in the application properties, and hence only then we would be able to run our second application. So here we can write server dot port is equals to 8081. Okay, now let me try it again. Run as maven build spring boot colon run. Apply and run. Let's see what happens now. So it is saying this port is also in use. Let me change here 036, as we have used the dependency devtool dependency, so it is getting updated already. Now, oh, Tomcat started on this port, that's why we were getting the same for the previous one. So in this way we can change the port, like no two services can be work on single port. So in this way we can work on this. Thank you.